Hello friends and hello student. My name is Ashok Sijala. In this session, we learn the suppress all the zero element at the bottom of dynamic array in C language. So let us start. First, I share my laptop screen and fix the position here so you can watch better my video lecture. And here Turbo C++. I double click and take some process. And now yes is open. Alt F file menu, in new file, and here our goal write a program to suppress suppress all zero elements yes elements at the bottom of dynamic 1D array. So that is a better. So yes, how suppress and what is this definition? So that is my always technique. What is the input, what is the output, and what is a process? So first I give one example. So what is our input? So like I give 5, that is a array of size. So 1, then 0, then 2, then 0, and then 3. So what is our output? So result. So that is a 1, then 2, then 3, and 0, and 0. So all if any zero element in the our 1D array, so that is a bottom of the our that array. So that is input and that is our result out. So and that we can use malloc and free or calloc or free function. So that is a dynamic 1D array. So that is very interesting definition. So now we can, yes, I give multi-comment line, that is your reference, so you can understand. And now we can first include our header file. So stdio.h, and then you can say that on your console input output.h, and then third one, that is a malloc and calloc. So alloc, so alloc.h header file is required. And now void main we have to take, and that first we can declare that is a asterisk, that is a p pointer, then we can say that n size of array, then I and j. Yes, so that is the sufficient. And then clear the screen. So first we can input and output. So first we can scan the array size. So here we can give the message. So enter one dimensional array size. Yes, and scan the n variable. Only 4 integer variable we have used in this definition. So that is a n. And now we can allocate the memory. So uh, malloc, yes, malloc, and that is a n multiply size of, that is a integer data type. But you have to know the malloc return data type is a void pointer, so we can must typecasting is required. So integer, that is our array is integer, so we can typecasting in integer. If that character, so we can typecasting in character. And if that float, so floats. So which data type that array is declared, that data type we can typecasting. Because malloc calloc, that is return data type, that is a void pointer. And now yes, first I give that one message. So that is the outside for loop, enter 1D array elements. So that is a perfectly, and slash n. And now we can take one for loop. So I assign to 0, I less than n, and I plus plus. And now we can take one with index you have to scan and also print. So that is a p. You can also declare as a x variable. So that is a, I declare as a p for pointer dynamic array. So this and percentage d and ampersand p of I. So that perfectly. So first we can scan with index, and now print also I can just copy and paste. And here we can provide get ch, and also we can free. Yes, that is a free function. So we can pass as a p pointer variable. So that perfectly. And you have to know the rules of all for loop and decision. So whenever two statement, then brace is compulsory. But now this for loop we cannot brace because only one statement required. So yes, I remove the scanf. So we have to print just our array. So percentage d and slash n. So here we can provide slash n. So here is not required. And here I remove this brace, and also message we have to change, not enter but 1D one dimension, yes, 1D dynamic array, yes, one dimensional dynamic array. So yes, 1D array element R, yes, that also you can use as dynamic word. And now I think perfectly. So I can save this file. So 1D, and we can zero. So all zero elements suppressed at the bottom of the zero or array, not zero, but array. So yes, that file I overwrite, no problem. So first we can scan, yes, compile, and then run. So yes, scan is like three testing. So 1, 2, 3, yes, that perfectly. So look, so yes, with index scanning and printing, that is all are well, no any error. Yes, and now we can, that is our input, yes, that perfectly, and that is our output. So that is also perfectly. Now in between we have to take process logic. So how? Yes. So first, yes, again I copy, or that is a first you can type. So that is a same for loop, and that base is provided. So that is now we have to define our logic. But that one n minus one. So one element is compare not required. So at the last, so n minus one is required. And now we can provide if condition. So x of I equal to zero. If any zero element, so we can that taking all other element to the add forward, means that index we have to, means element with shifting. So again we can take one for loop. So that is we can use as a j. Yes, here I take as a j variable. So j equal to I, yes, and j less than n, and j plus plus. So that perfectly. And now only one statement in this inner for loop. So x of j, yes, and we can assign to x j plus 1. So that is a 1 index plus. So all if 0, so that we have to take that before that element we can shifting. So that perfectly. And next what to do? So if that is last element, so we can say that x n minus 1 index, and that assigned to 0. So if condition if true, then we can sure that element is 0. So that element we can add the last our index, that is a bottom of that array, and other element we can shifting before. So that is a perfectly. So that is just finish. So yes, that is a required to watch window, so you can better understand. So first we can, yes, give that is our means paperwork. So yes, here that output and input perfectly in this logic. So let us first check. So yes, here, yes, I told you you can declare as a x. So I directly type x, but here we can take as a p variable. So yes, that all are, I think, p variable. So yes, I change that e not x. So you can also use as a x variable, no change. So here is a p, yes, not x. And now I think perfectly. So there is a, yes, now that only. So now what to do? So I give 5, and first 1, then 0, 2, and 0, and 3. So that is our input. Yes, and that you can watch, that is our require output is perfectly. So all 1, 2, 3 is a go ahead and suppress 0 to bottom of the our 1D array, dynamic array. So that perfectly. But how it possible? Yes, I again run and give any size. So here I take like 6, and I give some different means element. So 4, 0, then 8, then 0, 9, and 0. You can look. So 4, 8, 9, yes, that is in sequence, but 3, 0, that as the bottom of the our 1D array. So let us take watch window so you can understand better. So Alter W and watch. Yes, Alter W and output. And yes, let us take this very interesting definition. So yes, we have to here set the watch window. So here first that p of I, that is our array, and then I, then j, and then n variable. So that perfectly. And here also that is a p of j, yes, and then p j plus 1. So what is this value? So that is very interesting. So now let us take, I run trace. So trace F7 function key, you have to know alter R. So trace into F7 function key. So I directly press yes. Now that start, that our output is clear now, yes, and enter 1D array. So I use phi size, and that is our means paperwork, means we have to give. So that is a scan. So I give 1. Now again that is a scan. So 0. Again that scan. So 2 F7. So it's 3, and again, so again 0, and now that is a complete. So 5 element, yes, scan perfectly. Now our logic is start. So I assign again that is 5, but now 0. Yes, that is a watch window. So yes, that is perfectly. So I now assign to 0. That message window is here. I close. So F7, yes, that is a p of yes. You can look first one. So yes, if condition is false, because that is a p of I, that is a not 0. So that is a directly I plus plus. So I is 1, and now that 0. Yes, if condition is true. So look how it's possibility. So here that is a j directly assigned to I. So I is 1. So j is also 1, and you can look that is a next element. So j, that is a first, that is our that element is a 0, but j plus 1 is a 2, our next element target. So that is a copy in that p of j. So p of j means that is a 0 plus that taking to the 2. So that element shifting to here. Yes. So that perfectly. So here you can look that is a I assigned to 2, means that is a 1 index. So 1 index, that is a 0, but now is 2, that swap. And yes, again here all element you can look here that j equal to I, and j less than n, j plus plus. So here j is 2 now only, and that again that is shifting. So now that 2 is here. So now 3 is come to that second. Yes, let us check. Yes, so you can look here j now plus plus. So you can j that is taking 3. So j index 3, and 3 is again that 2 taking plus 2. So that is again j plus plus 4. Yes, now that condition. So last n minus 1. So n is pi and minus 1. So that is already 0. Yes, that is 0. So that is a shifting all element. Now what to do? So again that is yes, now that is a I plus plus. So 2 index, that is a again compare. So I plus plus. So 2. Yes, and that is a element is a, you can look in the watch window. So that I assign to 3, because that is a shifting here 2, and here is a 3. So all 1 2 3 is here, so not 0. Yes, so that is a I directly plus plus. So 3 index, that is a 0. Yes, if condition is true. But you can look here directly I assign to j. So that 3, and that is the same 0. J plus 1 is 0, and that is a 3 index is also 0. So that is 0 e plus 0, again that condition, and then 0. So all perfectly. So yes, now that is completely. So you can look that is 1 2 3. So first that round, that only 2 0 is that 1 2 is red, and all bottom, that is a suppress, means that all 0 in the bottom of our 1D array. So I think you have to understand. Yes, I taking as a watch window. You can also take different means example. So means even odd element. Yes, here I did 5. You can 6 7 8, different that size of array. And yes, if you use as a calloc function, so here just asterisk to 2 argument, and that is no any change. So let us I compile. Yes, there is no any error. So malloc and calloc both we have to use and give the 6, and then 1, then 0, 2 and 0, 3 and 0. So you can look 1, 2, 3 and 3, 0. So any definition, so any number of 0 that is taking from the bottom of the 0. So that is our target. So yes, here that is perfectly, I think you can understand. So what is that is a very interesting definition. So now we can complete. So yes, we have to take. Yes, I. So any doubt of this definition, you can write in the comment line. I give the definitely to answer to you. Thanks. Yes, any. So subscribe my channel Ashok Sijalai, press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.